Hey Algebra, how are you? Why don't you kick back, take a load off, put your thinking cap on, and let's talk about compound inequalities. Sometimes they're going to write an inequality, basically kind of two inequalities, and they're going to almost smush them together, and that's called a compound inequality. We could write one like this. Let's say it was -3 less than x, or let's say x plus 1 even, is less than or equal to 4. This is really, if you look at it, it's two inequalities. It's x plus 1 is greater than -3, and x plus 1 is less than or equal to 4. Notice the word I said there? I said and. Do you remember that, what's it called, Saturday morning, I can't think of what those are called. Anyway, conjunction junction. Let's see, what was that like again?
Conjunction junction, what's your function?
Hooking up words and phrases and clauses.
Conjunction junction, how's that function?
I got 3 favorite cars that get most of my job done.
Conjunction junction, what's their function?
I got and, but, and, or. They'll get you pretty far.
Oh yeah, there it is. Schoolhouse Rock. Anyway, and is a conjunction, and means both together. Okay, if I'm going to go play basketball and stop and get a Diet Mountain Dew, well, I'm going to do both those things. I'm not going to do one or the other. And later on, we're going to do a situation with or. Or means one or the other, but not both. Okay, and though in this case means we're looking at where both these things are true. The way you solve something like this is, why don't you just break it up into two inequalities? So -3 x plus 1. Okay, you know how to solve that. We just move the 1 to the other side and make it x is greater than -4. And then we also could have written x plus 1 less than or equal to 4. Move the 1 to the other side, x is less than or equal to 3. Now remember, we're looking for where both these things are true. So when we graph this, okay, if that was 0, 1, 2, 3, 4, this would be -4. X greater than -4. So remember, it's going to be an open circle, and I would shade everything to the right here in, except I really don't want all that. I only want the part that makes this true and this true. So this is one endpoint, and let's look at our second endpoint. X is less than or equal to 3. So 1, 2, 3. I'm going to have a closed circle there. And I want everything less than that. So greater than that, less than or equal to that. So what I'm really going to end up shading in is just this part of the line, okay? Okay, does that make sense? So, and separate them if you need to. Solve both of them. Figure out your two endpoints, and wherever they overlap, that would be the case. That would be what's going to be the part you shade in. If you ever had, something like where it was shading to the left of this and to the right of that, well, there would be no overlap, and so you would just have an empty graph. All right, let's do a situation where it's or. First of all, you can't smush them together like that when it's or. So let's say it was x is greater than 2 and x is less than or equal to -1. All right? And they said or. So this situation, there's really nothing to solve. Maybe I could make it more complicated if it was, x minus 2 is less than or equal to -1. So you know how to solve this. You just move that to the other side. X is less than or equal to +1 in this case. And this is already fine. So we're going to graph both of these things. So x greater than 2. There's 0, 1, 2, and we don't want the 2, so we're going to put an open circle, and everything to the right is shaded in, including the arrow. And we also want x is less than or equal to 1, so I go to 1, put a closed circle, and everything to the left of that is going to be shaded in. So this is a situation where it's or. It's this one, or it's this one. Okay, so both things get shaded in. All right, there's compound inequalities. Hope that helps.